Here we're talking about taking individual atoms and putting them together to make a compound. When we do that, we're focusing on chemical bonds, and there's a few different types of chemical bonds, but all of them are governed by many of the same rules. It's the attraction between our charged particles that's holding them together. And when we are attracting them, we are trying to become more stable. So stability really has to do with energy or lowering our potential energy. That means putting oppositely charged things as close as possible while putting similarly charged things, like two nuclei, as far apart as possible and balancing those. One key idea that connects bonding to other topics, thermochemistry, thermodynamics, and even can come up in equilibrium and acid base, is the idea of breaking and making bonds. So it's important to recognize whenever we break a bond, any type, and this is also true for other attractions we'll talk about later, like intermolecular forces, but breaking an attraction requires energy. It's like taking two magnets that are stuck together and ripping them or forcing them apart. That requires work and energy. When I form a bond, we don't think of the term making a bond or even forming a bond. What's happening is we are allowing charged things to come together. When we think of it that way, it makes a little more sense in terms of energy. Things that are attracted to one another are being allowed to come together and attract. That's why it releases energy. We can think of that in terms of magnets as the click or the sound that is made when they finally do come together. An important equation, and it's later in the notes, I'll actually end up deleting it out right here because we won't use it a lot, but it's delta H, the change in energy for whatever process we're looking at, whether it's dissolving, whether it's a chemical reaction, whether it's a change of state. That energy change for that process is equal to how much energy it took to break all of the attractions minus how much energy was released when all of the attractions were formed. Bond energies are always given as positive values, so this is why that is a positive, and then we do minus to account for the exothermic or release right there. That's an important equation. It is not one that is given because we really want to focus in and understand this concept, the endo-exothermic part of these attractions and bonds that we're looking at.